So now that we have something that will help us to actually output things to standard out, let's use it again. And so you don't even have to get rid of your write.s. You just leave it just how it is. And we're going to include that in this program as well. And as you do this on your own, you may develop your own library of things that you use over and over again. We'll do a couple of programs in this set that are reusable. And so we'll use this write.s over and over again for our null write. But for this exercise, we're going to work more with the branching and the looping. And so our problem is that we want to get rid of the double letters. And if we think about it, if we talk through it, what we need to do is we need to read a letter and see if that letter matches the last letter that we read. And if it's the same, then we need to do nothing with it. But if it's different, then we should write it to output. As you can see, the end string here is I just want this stupid thing to work. And I didn't feel like counting how many letters that was. And so for the output, I just said we'll reserve 128 bytes, which I knew was more than enough. So let's actually work on this. The first thing that we need to do is we actually need to load the input and output strings. We need to load the addresses so that we can access the memory. And so the first thing we should do is load register. We'll use R0 for the input string. And we'll use R1 as the output string. What we're going to start doing now is also up here, we're going to create a part in the top of this file, and we're going to call it registers. And we're about to get into more complicated programs where it's going to be very important to keep the registers correct in our head. And since we can't name them anything, we can't say, okay, we're going to call register 0 input string and then refer it to input string throughout the whole program. We need some kind of guide, some kind of table of contents that gives us an overview of how we're using these things. And so up here, we'll just put register 0 will be the input string address, and register 1 will be the output string address. The other part that you may be thinking is in the pages in the book, it says not to use register 0 through 3 unless you're using functions. Well, we're not really in that complicated code yet, so don't worry about it. We're just keeping stuff in order right now. So now that we have the input and the output, let's actually write the meat of the program, the actual loop that's going to do all the work. We'll use the label loop. And the first thing that we need to do is we need to load a byte from memory into a register so that we can work with it. We can use register 2 because I can come up here and see that it's not being used yet. And so we'll say register 2 will have the temporary byte read. And we do this with the load register byte. R2 is we just put the address at R0 because we're reading from the input string. And what we're going to do is put a number 1 here. And what this does is it's a post index. And so we're going to read the address at register 0, but then we're going to add 1 and move the what you would call like a pointer in some languages. We're going to increment the address 1 so that it points to the next memory address. So what this does is it saves us writing add register 0, 1 in the next line because this instruction kind of takes both of those and does it in one instruction. The next thing we need to do is we need to figure out what this thing is. We want to compare it First of all, to 0, because if it's a 0, then we know we've got to the end of the input string. So let's do that first. We'll use the CMP instruction, which is compare, and the value in R2, and we'll compare it to 0. And so what's very important here is that compare works by subtraction. Internally, what the processor is doing is it's taking the first number and it's subtracting the second number, and then using that value to set the current program status register, the CPSR. The suffixes that we'll use in the next couple of programs, actually throughout the whole thing, are geared for the comp instruction. For instance, for this one, we're going to say if it's equal, we want a branch. So we'll say b equal, branch if equal, and we'll go to a label that we'll call exit. And so we can put the exit label down here and we'll get there. But what the processor is actually doing is saying, okay, R2 minus 0, and then using that. So if we do have a null character, it's going to be 0, and so 0 minus 0 is 0. If we had something that wasn't 0, what would happen is we'll say it's 32. 32 minus 0, well, it's still 32. And so since the equal flag checks to see if the 0 flag is set, it will not be set with a result of 32, and it won't trigger the equal flag. If we were using a different comparison operation that did something like a bitwise and or a bitwise or something like that are there that we haven't gotten to, the branch if equal will make no sense because it's not necessarily going to be equal. And so it's very important while you're doing these, especially when you're learning the conditional codes, to keep this little table next to you that was in the website so that you can say what flags are actually being tested. Because some of those flags we can use in different ways, even if we don't use the actual comp command. Regardless, if equal, we hit the end of string. If it's not equal, though, we need to figure out, if it's not 0, if it's not an all character, we need to figure out what to do with it. Do we write it to the output or do we skip it? And so we need to compare this to a different value. And we're going to have to compare it into a value that's going to change. And so let's put it in another register. And we'll come up here and we can see that register 3 is open. And we'll say register 3 is last read value. When the program starts up, theoretically, all the registers should be set to 0. However, what I like doing many times is that I like having an initialize section at the top, just so that I can see and have another reference of what it actually is. So that if I'm scanning the code, I don't have to guess, oh, was this set in another function in a different file, or is it supposed to be 0? I like actually putting something here that says that register 3 is set to 0 at the beginning. And sometimes the compiler will turn this into a no operation. But even if it actually sets the register to 0, you're not losing a lot of time. And I find that it saves a lot of time to actually just go back or be able to read the code and say, oh, it is set in this file. It's set right here. And that's what's happening. And the reason we set it to 0 is because we know that it's never going to be 0. So if we had an input string that wasn't a string that had no characters, we'd have an undefined behavior. But we know we don't. So if we come back down here, we'll then compare R2 to R3. And if it is equal to the last value, we don't want to do anything with it. We just want to drop it and read the next character. And so again, we'll do branch if equal, and we want to go back to the beginning of the loop to read the next character. If it's not equal though, what we want to do is we want to take this character that we just read and write it to output, and then store it to the last read value. So we'll use this store byte, and we want to store what's in R2 to the address at R1. And again, we'll use the post index instruction and put a number 1 here so that it automatically increments the output address for us. And then what we want to do is copy this value into R3, the last read value, so that we can compare it to the next value that we read. And to move values between registers, we'll use the move command. After that, we want to do an unconditional branch back to the beginning of the loop because we've already done all of our processing. And so that's the meat of the program. That is those 1, 2, 3, 4, 5, 6, 7, 8 lines are pretty much everything that we need to make this program work. After we process the whole line and we process everything in there, what we want to do is we want to write what we got to verify that we got rid of all the duplicate letters. And so we'll use the macro that we used or that we wrote, the null write, and it's as easy as going null write and then outstring. That's it. We don't have to set it up anymore. We don't have to worry about any of that. And then set up the exit. I don't know why I never put the exit in a macro. Again, it's something that you could create a macro for with no arguments and just say prog exit or something like that. So let's do this. We're going to move into R7. The number of this is call for exit, which is 1. And then our only parameter is the error code, which is 0 for this. And then SVC 0 will actually execute the call. So let's try compiling this and running it and see what we get. We'll assemble it first. Our output is going to be main.o, our input is main.s. Link it, output's going to be main and our input is main.o. If we run it, we get the expected result. And so now we're starting to finally get into things that are using loops and comparisons, and these are really the building blocks of a programming language. And pretty soon we're going to be doing some pretty complicated things with the 16 or so instructions that we actually have in this language.